Everyone, welcome back to the second video of sine and cosine problems, mixed problems. This one we're going to have a look at a bearing problem. So we've got a harbour, has 3 marker buoys to warn boats and other water vehicles about dangerous undercurrents in the harbour. Buoy 2 is 240 away from buoy 1 on a bearing of north 6415 east, and buoy 3 is 160 away from buoy 1 on a bearing of south 19 degrees 30 minutes east. So the first thing to do is draw this diagram to show the position of the buoys, the distances and the bearings from buoy 1. Okay, so both of the positions of buoy 2 and buoy 3 are in relation to buoy 1. When you're drawing these diagrams, try to get your angles about right, try to get your distances about right, okay, because it'll really help you piece it all together. So if it says 64 degrees, make it about 64 degrees. If it says 19 degrees, make it about 19 degrees, okay? So 64 is 2/3 of the way around here, okay? So just be aware of that, make it part of the learning of how to do these drawings. It's important that you can draw them, okay? So what I did to approach drawing this was, because each of the other 2 buoys is in relation to buoy 1, I drew buoy 1 first. So I drew, there it is, there's the buoy. Over that, draw a set of compass arms. Otherwise, you'll have no idea where to draw these other ones, because you need the compass arms to strike your bearing, and so you know which distance, which direction it's off in, okay? So to draw buoy 2, it's 240 away on a bearing of north 6415. So 64 degrees is about that much, about 2/3 of the way around, and I drew in my 240. Okay, put another point there, drew another set of compass arms in. Okay, then I looked at buoy 3. Buoy 3 is 160 away from buoy 1 on a bearing of south 1930. So once again, south 1930 is south, back this way about 20 degrees. All right, so that's 30 degrees in there roughly. That's a little bit less than that. That's about 20 degrees, okay? And when I drew that line, I made it around in proportion to this one. If that's 240 length, that's about 160. It's an estimate. I didn't get a ruler out. I just estimated it, okay? So it's fairly important that you scale it approximately, okay? So then once I've got, there it is there, for buoy 3, I drew in some more compass arms. And then I reconnected to make a triangle, because this is trigonometry and we're dealing with triangles at the moment, okay? And then I drew in, that's 240, 6415, 1930, 160, okay? So then what I did, excuse me, determine the angle between buoy 2 and buoy 3 from buoy 1 to the nearest minute. So buoy 2 is there, buoy 3 is there, buoy 1 is there. So the angle between 2 and 3 is this blue angle here. So we're going to work out that angle, okay? So what I did is I looked at what information do I already have that can help me calculate that unknown angle. And what I've seen there is that I've got an angle here that's been given to me. I've got an angle here that's been given to me. And the other angle that's missing, all 3 of those make up a straight line. So you've got to be on the lookout for these things, okay? So all 3 of those are on a straight line. Therefore, 19 degrees 30, 6415, and my unknown are all going to add up to 180, angle on a straight line. So determining angle A was fairly straightforward, okay? So angle A is going to be 180 minus those 2 added together, taking both away from 180, and we end up with 96 degrees and 15 minutes for this blue angle here, okay? So 96 degrees and 15 minutes, okay? So that's A is done, B is done. relatively straightforward. To the nearest minute, there it is there to the nearest minute. So these here, you need to be making sure you're using your degrees, minutes, seconds input. Okay, so 180 minus bracket, click on your little button underneath the, bring it up here so you can see it. Little demo. Okay, so here, that button there. So you can put it in degrees, minutes, and seconds, and I'll give you a little demonstration. Okay, so 180 minus, whoops, I'm going to get rid of that, sorry. All right, so 180 minus the sum of 64 degrees 15, so in degrees, minutes, and seconds, 64 degrees 15 minutes plus 19 degrees 30 degrees, minutes, seconds, 19 degrees and 30, enter. Notice how it's going to give it to me as a decimal. If I go control enter, that gives it to me as a decimal. That's not degrees and minutes, that's a decimal equivalent. So remember to go to degrees, minutes, and seconds. You go back to your catalogue book, and if you've used it before, it should come up. If not, type D, scroll down to 2DMS. This was in one of the other videos. 2DMS, enter, and enter 96 degrees 15 minutes, and there we have it. Okay, so that's, remember, you need to be able to do that. Okay, so that's done. Part C, determine the distance from buoy 2 to buoy 3. Give the answer to 2 decimal places. So let's look what we've got. It's not a right angle triangle, clearly. It's not a right angle triangle. Okay, so Sokotoa and Pythag, no, absolutely not. You'd be surprised how many people try this on, but it's not going to work for a non-right angle triangle. Okay, so what we need to be doing is thinking in terms of sine rule or cosine rule. So when you've got two sides here, known sides, and we have one angle which is included in those two sides. So the two known sides make up the known angle. It's an included angle. So if you have a look at your coloured sheet, if you've got a non-right angle triangle where you have two sides and an included angle, then you can use the cosine rule to work out the opposite side to the known angle. Okay, so what I've done is I've labelled this A. Opposite will be lowercase a, B and C, where B is 160 and C is 240. Okay, so then let's look down here. We've got A. We need that because that's what we're trying to calculate, the distance between buoy 2 and buoy 3. Buoy 2 and buoy 3. Okay, from here. We have angle A, tick. We have B, tick. We have C, tick. And A is included in B and C. It's an included angle. So we're going to use A squared equals B squared plus C squared minus 2BC cos A. Right, so here's a summary. Distance from 2 to 3, we have two sides and an included angle. Therefore, the cos rule applies. So subbing all of that in. And what we can do is you can take the square root of all of that because you're looking for A. So to get A from A squared, you take the square root, and we end up with 302.59 metres. So that's 302.59 metres. Okay, and that's to 2 decimal places, tick. All right. Okay, so the last bit, this is where it can be a little bit involved. What is the reduced bearing from buoy 2 to buoy 3? Okay, from buoy 2, so we're standing here and we're looking back at buoy 3. From 2, so that means we're measuring with our compass here, where you're standing from. Now, a reduced bearing is always going to be between the north compass arm or the south compass arm. So it's either measured from north or from south, and then here's the sight line back to 3 from B to C, or from 2 to 3. So the reduced bearing is going to be measured from the south compass arm back to that sight line. So I've just called it little lowercase d, okay? So that little angle is the angle we're trying to calculate. Okay, so reduced bearing from 2 to 3. We're each going to pop over to the next page and we'll come back afterwards. Okay, just one. All right, so okay, so we're looking for angle D, this little angle in here, and that's the reduced bearing from B to C, south something west. Now, a hint here for doing these questions is always look for alternate angles, Z angles. Always look for Z angles, okay? So let's see. I know this angle here, so a Z angle might be there, there, and there, which is that angle there. So that's one I could consider, okay? Another Z angle could be there, along there, and along there. That's another Z angle. Okay, because I'm interested in Z angles that are relating to this angle here that I'm trying to find. Okay, so I've got one there, and I've got one there. Okay, so I could say, okay, well, that one there, that means that from there to there is 64 degrees 15. Okay, which means that that angle there plus 64.15 would add up to 90. That includes my angle as well, but I'm not sure if it really helps me that much. But that gives me a bit of a hint as to what that angle might be. Okay, so 64 degrees 15. So 64.15. If I take that away from 90, that'll give me that angle there. Okay, that could be helpful. That's why I've got a little asterisk there. Another way of looking at it, if I go along there and along there and along there, that also gives me that angle. How might I find that angle? It's a couple of ways. Well, 90 takes 64.15 is one way. And another way of looking at it too is we've got, I think it's probably the easy way of doing it actually. Taking, you can see here that 64.15 plus that little angle equals 90. And then I can transfer it up here by alternate angles. So this angle at A, so the angle, this one here, is 90 takes 64 degrees 15, which is 25 degrees 45 minutes. That's that angle there. So by alternate angles, I can transfer that up here by Z angles, okay? So then I could say, well, if that's 25, 45, if I knew that angle, then I could take both of those away from 90 and I would have my bearing angle. So it might be helpful if we knew angle B. Okay, so just backtracking a little bit, by alternate angles, this angle here at B, we can work that out. To determine the bearing angle D, we must also consider the triangle angle B, which is this triangle angle here. Because we know all the three sides, we can use the cosine rule to work out that angle. So if you look at your coloured sheet that I gave you, when you're using cosine rule, if you know all three sides, you can work out any angle. Okay, and remember, we worked out that side A from over the page, we worked out that A was 302.59. So 302.59, B is 160, C is 240. Okay, so what we can do is we can do it this way around, cos B, because that's the angle we're looking for. So BCA, BAC. So if we're working at angle B, it's C squared plus A squared minus B squared over 2 times A times C. C times A, same thing. Okay, so cos B is all of that. To work out the angle, remember we take cos to the -1 of all of this. So I can just do it all in one step. Okay, so if you go cos to the -1 of C squared, 240 squared, plus 302.59 squared, which is A squared, minus 160 squared, which is B squared, over 2 times C times A, or 2 times A times C. Hit enter, you get 31 degrees 42 minutes. You'll probably have to convert that into degrees, minutes, seconds. So we've got 31 degrees and 42 minutes in there. Okay. We've also got this angle here we're trying to work out, and this angle in here was 25 degrees 45. 45 minutes, because that's what this was, 64 degrees 15. Take that away from 90, 25, 45. Okay, so then all three of those are going to add up to 90. You see that? So that means that 25.45 plus 31.42 plus our unknown bearing angle equals 90. Take them both away from 90, make D the subject. We determine that D is 32 degrees and 33 minutes. So that's 32 degrees, 30 minutes. And that's our bearing angle. So we're from the south compass arm, 32 degrees, 30 minutes towards the west. Okay, so we'll just go back a page. So down here, reduce bearing from 2 to 3 from over the page that we just did. Bearing of 3 from 2 is bearing from 2 to 3, bearing of 3 from 2, that's right, from 2, is south 32 degrees 33 minutes west, and the distance is 302.59. Okay, that's a reasonably involved question. It's representative of the types of questions that we get with these mixed problems. You need to, first of all, be concentrating on your diagrams, as always, and then you need to be trying to use things like alternate angles and angles that add up to 90, angles that add up to 180, to piece together all the information that you need to be able to solve these problems. Okay, and the information that you determine, the information that you include in your triangles will determine whether you're using sine rule or cosine rule. Okay, so I'll be standing by to give you a hand with these. So drop back into the meet as you do your questions, and we can do some tutorials. Okay, thanks everyone.